problem 1163, last substring in lexicographical order. So for this problem, we are given a string s and we're going to return the last substring of s in lexicographical order. So for string s, we're going to have something like a, this is a substring, or ab or aba. So everything going to be inside this array. And we're going to return the last one in lexicographical order, so it's going to be BAB. As we can see from the example, it must be a suffix. I mean, the final result must be a suffix. So for example, this is a BAB, and the BAB is the suffix of the string, and this T code is also a suffix of the string. So this is obvious, and we should know about it. It must be a suffix of the string. And the length of the string is 4 times 10 to the power 5. So this means we cannot solve it by using the brute force. Even though we know that this string is a suffix, but we cannot use the brute force to compare one by one until we find the final result, because that's going to be n squared times complexity. Definitely it didn't work. Basically, we're going to use O(n) time to solve the problem. We're going to use linear time. So an easy way to solve it is by using two pointers. So let's just use an example. So for example, we have AB and AB. So the first pointer we're going to set is I, it pointed to A, and the second pointer is going to be J. So J going to equal to I plus 1 from the beginning. And then we're going to compare one by one. So A not equal to B. So this means B is bigger. So this is A is not a result, it must be a B. Yeah. But what if this A is more than B? This means A is still the possible result. And still we're going to need another variable K equal to 0. So this is going to be a counter. So I going to starting from 0, J going to starting from 1. So J going to be I plus 1, going to be 1. And then we're going to use this K as a counter to count one by one. So first of all, this A is not more than B. So this means the pointer I going to be updated to the position of J. Yeah. So this is going to be the I. And what about the J? Normally the J would be I plus 1. So J going to be here. Yeah. And then we're going to continue to compare. So this B is more than A, and we're going to shift to the J. So J going to be updated to here. So this is a J. Yeah. Now we're going to continue on to compare. This is equal, and we're going to J going to update it to the next one. But for this J, it goes out of the boundary, so we're going to stop the while loop. So the final answer must be a suffix. So instead of this B, it's going to be BAB. So the final answer is going to be SI with the suffix. So this is going to be the final answer. But this is just an example, an easy example to consider. So while we're going to update it, so the pointer J is going to be I plus 1. So this is only one case. But what about another one? Let me use another example. So we're going to use something like maybe, yeah, let's just use this one. We're going to use something like BBB. We have 4B, and another one, let me think about it. Maybe I'm going to use C. Yeah, of course we know the final result is gonna be this character. It's gonna be this character C, right? Yeah, but how are we gonna compare? So this is I and this is J. So Si equal to Sj, we're gonna update it. So the K gonna plus 1. So I plus K, J plus K, it's gonna be here, and then it's gonna be here. Yeah, so K gonna equal to 3, I is 0, and J is 1. So 0 plus 3, it's gonna be this position 3. Yeah. So for J plus 3, it's gonna be this position at C. Yeah, but currently this one is bigger. So this C is bigger. So this means we need to update the I. Let me think about it. Yeah, we need to we need to update the I. So this means, yeah, because this definitely this character C is bigger. So this means we need to update the I. But we cannot update the I, so the I gonna equal to J. Yeah, so I gonna be here. So at this present, it's gonna be the new I. So what about the J? So normally the J gonna be I plus 1. But as you can see, it is too slow. This is the O(n) square. Definitely we're gonna use O(n) time. Yeah. So actually J cannot be updated here because we have already counted. So actually J gonna be the maximum of I plus 1. Yeah, it's gonna be the maximum of this this I plus 1 with I plus K plus 1. So actually this gonna be the updating of the index J. It's gonna be the maximum of the two. Because all those bits have already been counted, we will not repeat the calculation again. So we just need to use the maximum of I plus 1 is going to be here, I plus K. So I is 0 from the beginning, 0 plus 3 plus 1 is going to be 4. Yeah. So the pointer J going to be updated to here instead of the next one. As you can see, there is a big jump. Yeah, because the J going to be updated here. Because for B, we didn't find the value, so the J going to be updated to here. Now we're going to compare Si is less than Sj. So this means C is the final result. So I gonna be updated to here, and J gonna be J plus 1. It goes out of the boundary, so we're gonna stop the while loop, and the final answer gonna be Si, and this gonna be this character C. Yeah. So this is the difficult part. If we have such cases like BB with a C, we need to use the maximum of I plus 1 with I plus K plus 1. Yeah. Now let's just start coding by using two pointers. So we're gonna prepare I, J, and K. So I gonna be on 0, J gonna be 1, and K gonna be 0 as well. So we're gonna check while J plus K is inside of the boundary, and we're gonna check if Si plus K equal to Sj plus K. So this means those two strings are equal. If those two strings are equal, so we just need to update the counter. So J K gonna plus equal to 1. And if Si plus K is let me think about it. If yeah, it is less than Sj plus K. So this means I need to update the pointer I and J. So I will give a pause and I will write it later because this is going to be a little bit difficult to write. And else this means Fi plus K is more than Sj plus K. So I just need to update the pointer J. And finally I need to return Si with a slice. Yeah. So I need a Si with colon. Now let's just write this part. So I'm gonna assign the I pointer to T because I will use it later, and I'm gonna update the pointer. Yeah, let me think about it. I'm gonna update the pointer I, so I gonna equal to J, and J gonna equal to the maximum of J plus 1, the next person, and the I person. So the previous I person is T, so T plus K plus 1. So you have to understand it, otherwise you cannot solve it. So after that, we're gonna update the counter. So K gonna update it to 0, and here as well. If we were to update the person, so the counter gonna update it to 0 as well. Yeah. Now let me just run it and submit it to check if it works. As you can see, it works and it's pretty fast. Yeah. So for understanding the problem, we have to use some examples to understand it. So for example, this is BB, and C. So what are we gonna do? So from the beginning, this is I and this is J, and then we're gonna check as I plus K equal to 0, this one equal to this one, and then K gonna plus 1, so K gonna be 1, and then this B equal to this B, K gonna plus another 1, K gonna equal to 2, and then we're gonna compare this one equal to this one, so K gonna become 3. So K becomes 3, so for the next person, so this gonna be the so I plus 3, 0 plus 3 and 1 plus 3, so it is at this place in capital C. So J is 1, 1 plus 3, it is 4. So S3, it is B, is less than S4, it's going to be C. But yeah, it is less than C. So what are we going to do? We're going to, first of all, we're going to assign this I to T, and I going to equal to J. Yeah, so we're going to be the I. So here going to be the I, because I equal to J, and J going to be the maximum of the two. So J going to be here at place in capital C. Yeah, and K going to be updated to 0. And then we're going to continue, because this capital B less than this capital C. So what are we going to do? Yeah, we're going to continue the calculation. So I going to be here, and J going to be the next place, but if it goes out of the boundary, so we're going to choose this capital C. So this is going to be the final answer. So this is also a suffix. Yes, I think the difficult part may be this area, except that it's going to be easier to understand. Basically, it is a two-pointers solution. Thanks for watching. See you next time.